For 35 years, Voyager 1 traveled through the darkness, alone, silent, racing toward the edge of everything humanity had ever known. And then, in August 2012, its instruments began detecting something impossible. The numbers didn't make sense. Cosmic rays spiked 9% in a single month. The solar wind vanished. And from the void beyond our sun's protective bubble, Voyager heard something no one expected. NASA scientists stared at the data in disbelief. For decades, they'd imagined the boundary of our solar system as a calm, invisible wall, a quiet threshold separating us from the cold emptiness of interstellar space. But Voyager 1 had just crossed that line, and what it found wasn't empty at all. It was alive. The space beyond our sun's reach wasn't the serene void scientists predicted. It was turbulent, pulsating, dense with energy, and it was doing something that rewrote everything we thought we knew about our place in the galaxy. If what Voyager discovered is true, then our solar system isn't the fortress we believed it was. It's something far stranger and far more fragile. To understand what Voyager found, you have to understand what it was supposed to find. When NASA launched Voyager 1 and Voyager 2 in 1977, their primary mission was to explore Jupiter and Saturn. No one expected them to leave the solar system, but year after year they kept going, past Neptune, past Pluto, past the orbit of every known planet. By the early 2000s, Voyager 1 was more than 100 astronomical units from the Sun, 100 times farther from the Sun than Earth. It was entering a region called the heliosphere's edge, where the Sun's influence should end and the galaxies begin. Scientists pictured this boundary like the hull of a submarine, firm, protective, separating two completely different environments. Inside, the solar wind, a stream of charged particles blasted out by the Sun. Outside, interstellar space, the ancient sea of gas and magnetic fields that flows between the stars. The crossing should have been clean, predictable, quiet. It was none of those things. On August 25, 2012, Voyager 1 became the first human-made object to leave the solar system. But the transition didn't happen in an instant, it happened in waves. First came the cosmic rays, high-energy particles born in the explosions of distant stars. Inside the heliosphere, the Sun's magnetic field shields us from most of them. But as Voyager approached the boundary, cosmic ray levels began to climb. 5% in 1 week. 9% in a month. At the same time, the solar wind collapsed. The stream of particles from our Sun, particles that had surrounded Voyager for 35 years, suddenly dropped to nearly zero. Every sensor confirmed it. Voyager had crossed into interstellar space. But then the instruments detected something no one anticipated. The plasma wave experiment, an instrument designed to measure electrical vibrations in space, picked up a signal, faint, rhythmic, persistent. Voyager was hearing the interstellar medium. And it wasn't quiet. Plasma is the fourth state of matter, a gas so hot that its atoms break apart into charged particles. Space is full of it, but scientists believed interstellar plasma would be thin, diffuse, barely measurable. Voyager's instruments told a different story. The plasma density outside the heliosphere was 40 times higher than inside. 40 times. Imagine standing in a quiet room then stepping outside into a roaring ocean. That's what Voyager experienced. The interstellar medium wasn't empty, it was dense, cold, and buzzing with electromagnetic energy. Scientists detected bursts of sound they called whistles, brief pulses of plasma waves triggered by solar storms that rippled out into interstellar space. Years later, they found something even stranger, a continuous hum. A faint, low-frequency drone that never stopped. It was the sound of the galaxy itself. For the first time in history, humanity wasn't just observing space from Earth. We were listening to it from the outside, and the universe was far more alive than we ever imagined. 6 years later, on November 5, 2018, Voyager 2 crossed the same boundary. But here's the mystery: Voyager 2 was following a different path than Voyager 1. And when it crossed into interstellar space, the data didn't match. The boundary had moved. Scientists discovered that the heliosphere, the Sun's protective bubble, isn't a rigid shell. It ripples, it shifts, It breathes like a living membrane, expanding and contracting with the rhythm of solar storms. Data from NASA's IBEX satellite confirmed it. The heliopause, the name for this boundary, doesn't sit still. It bobs and oscillates, pushed outward by the solar wind and squeezed inward by the pressure of the galaxy. Between 2012 and 2018, the boundary moved so much that Voyager 2 crossed in a completely different location than Voyager 1. Think about that. The edge of our solar system isn't a wall. It's a dynamic, shifting frontier sculpted by forces we're only beginning to understand. But the surprises didn't stop there. Voyager 2 made another discovery that shook the scientific community. Our sun's protective bubble is leaking. Scientists always believed the heliosphere acted like a barrier, keeping solar particles in and galactic particles out. But Voyager 2's instruments detected something unexpected: tiny flows of solar protons well beyond the heliopause. Solar particles were bleeding through. Somehow, charged particles that should have been contained inside the heliosphere were escaping into interstellar space. The barrier wasn't sealed, it was porous. And then Voyager 1's magnetometer added another puzzle. Magnetic fields have direction, they point somewhere. Scientists expected the magnetic field in interstellar space to be chaotic, twisted, completely different from the sun's magnetic field. But it wasn't. The magnetic field lines just outside the heliosphere were nearly parallel to those inside, as if the sun's magnetic influence was reaching farther than anyone thought possible, as if our star's field was somehow entangled with the galaxies. It was like discovering that your house doesn't have walls, just a thin curtain separating you from the storm outside. 11 billion miles from Earth, Voyager 2 drifts deeper into the unknown. Commands from mission control take more than 16 hours to reach it. Responses take another 16 hours to return. Every instruction is a conversation across the void, stretched across time and distance most of us can't fathom. And yet Voyager still speaks. In 1990, Voyager 1 turned its camera back toward home and captured what Carl Sagan called the pale blue dot, a single pixel of light in the vastness of space. Earth, all of us, every human who ever lived, contained in a speck barely visible against the cosmic dark. From 3.7 billion miles away. Even Jupiter was just a pixel. Voyager's family portrait of the solar system reminds us of the scale we're dealing with. These spacecraft didn't just leave our planet, they left our sun's embrace. They crossed into a realm where the rules are different, where our star's voice fades, where the galaxy takes over. And they carry something with them, the golden record, a message from humanity, sounds of Earth, greetings in 55 languages, music, laughter, the cry of a newborn child. If anyone or anything ever finds Voyager, they'll know we were here. They'll know we wondered what was beyond. But perhaps the most shocking discovery is what Voyager didn't find. For decades, astronomers predicted a hydrogen wall at the edge of the heliosphere, a glowing pileup of hydrogen atoms where the solar wind collides with interstellar gas. Models suggested it would shine faintly in ultraviolet light, marking the boundary like a cosmic lighthouse. Both Voyagers searched for it and found nothing. No bright halo, no hydrogen wall, nothing. Recent observations from NASA's New Horizons probe confirmed it. The wall simply isn't there, at least not the way scientists expected. Instead, researchers now believe our entire solar system is drifting inside a much larger bubble, a region of hot, low-density gas created by supernovae that exploded millions of years ago. The hydrogen that should be piling up at our doorstep is being swept away by ancient stellar winds we didn't even know existed. It means our sun isn't floating in a neutral void. It's moving through the remnants of dead stars. We live inside a cosmic fossil, a bubble carved by explosions that predated human civilization. Everything we thought we knew about our neighborhood in the galaxy is being rewritten. Voyager 1 and Voyager 2 are now farther from Earth than any human-made object in history. They've entered a realm where the sun is just another star, where the plasma is denser, colder, and more turbulent than anyone predicted. They've shown us that the boundary of our solar system is not a fortress. It's a living, changing frontier that stretches, ripples, and leaks. A place where the sun's breath mingles with the galaxy's wind, a place where magnetic fields tangle in ways we don't yet understand. One Voyager scientist said it best: everything we're seeing is new. And that's the truth. Every signal Voyager sends back, every plasma whistle, every cosmic ray reading, every magnetic field measurement is teaching us something we didn't know. But the mission won't last forever. Voyager's power supply is fading. Within a decade, maybe two, the spacecraft will go silent. They'll continue drifting through the galaxy for millions of years, but we'll no longer hear from them. Until that day comes, Voyager keeps transmitting, keeps exploring, keeps whispering back from the edge of the unknown. And it leaves us with one question, a question that might define the next century of exploration. If we found this much mystery just beyond our doorstep, what else is out there waiting in the vast unknown just beyond our reach? If you enjoyed this journey to the edge of the solar system, subscribe for more documentaries that explore the universe's biggest mysteries.